Here's a question where they've mixed up a bit of graph sketching of cubics with coordinate geometry. Right, and we'll just take a look at what we need to do. Factorise, hopefully everyone can do that. X cubed minus 4x, take out the factor of x. Of course that's not fully factorised. We need to factorise that as well, and we need to recognise it immediately as a difference of two squares. About 3 of the most quickest and straightforward marks you will see on a C1 paper. Now B, sketching the curve. Okay, let's draw it here. Change colour. Right, now it's going through the axes this way, and we know it's going to be a cubic of that type because A is greater than 0. If it were the other way around, A were less than 0, it would be a cubic of that type. We know that it also, because of the x there, we know it goes through the origin, so it's just going to do this. There we go. So it's minus 2, 0, and 2. Another 3 very quick and easy maps for that one. Okay. Now for parts C and D, I'm going to take a little bit more work now. It says that the coordinate of point A has coordinate minus 1. Okay, here say. So we're looking for the point with a coordinate minus 1. And this one has a coordinate of 3. Up here, say. Clearly not to scale. Doesn't matter, sometimes we can have a picture of what's going on. Giving you so here we go. Giving you answer in the form y equals mx plus c. So I suppose the first thing to do is to work out the y coordinates. So I've worked them out down here. So let's do them. When x equals minus 1, y equals 2, and I use the original bit because there's only 2 bits to it, minus 1 cubed minus 4 times minus 1. Okay, and so that equals to, this bit equals, second bit is plus 4, it's minus 1, so that's equal to 3. So we've got the point 3 there. And then we've got when x equals 3, y equals to 3 cubed minus 4 times 3. That's 27 minus 12, which is 15. Okay, so we're being asked to find the equation of the line joining these two there. Okay, well now we've got two coordinates. Now we've got these two coordinates. I'll write them up again here. We've got coordinates A minus 1, 3, and B 3, 15. So we can work out the gradient delta y over delta x, or change in y over change in x. So it's 15 take away 3, and then 3 take away minus 1. So that's 12 over 4 is equal to 3. And then we can do y minus y1, or whatever there are. Some people just find c in the y equals mx plus c formula, which is also okay. So y minus y1, mx minus x1. If I put in my coordinate for point A, because the numbers are smaller, so I've got y minus 15 is equal, not 15, y minus 3 equals to 3, and then x plus 1. Okay, so that gives me y equals 3x plus 6. Okay, 3x plus 6, that's the equation. Right, now, part D is just to work out the length as a third, and there's a formula for that. It's basically based on Pythagoras' theorem, where you find a change in y over change in x. So you can say the distance is equal to change in y, or change in x, doesn't matter which way around you write it, take away plus, say, Pythagoras' theorem, y2 minus y1 squared. So that equals to the change in x, we can see goes from 3 to minus 1, so that's 4. The change in y goes from 15 to 3, so that's 12. So that gives us 16 plus 144, which is the square root of 160, which, if we break it down, is 16 the square root of 10. So it's 4 the square root of 10. That's it. And 13-mark question, actually done in about 6 minutes, half amount of time than is actually allocated, even with me talking through it. So it should be a case of picking up marks, and actually also, because it's relatively routine, picking up time as well. Okay, that's it.